Yeah. Okay, we will get started. Okay, so some students are online, and as I said last time, the classroom is not suitable for you to be on your laptop because there's no power supply at each individual desk, so you can always attend it online as well. Okay, we haven't been able to figure out a better classroom, unfortunately. Am I audible, or should I raise my voice? I'll try to raise my voice. Actually, I think I'm. Yeah, yeah. This machine is also in this room, attending our MLOps class. Okay, so logistics wise, I did have a couple of example presentations from either last time the course was offered or one before it. That's just a example for how to think about your projects. I'll go through the slides in a second. So that's in terms of logistics, and then we'll get back into what we were doing last time. So last time we were doing something to do with web app, web servers. Today the objective is actually, this is not a steep ramp. Today we just want to get into AWS or Google Cloud, one of these providers, and just try out a serverless demo. Okay, and for this, not just for this, for every lecture, the notes that you have in the repository in this folder are kind of not the first point of reference. The first point of reference is generally the tool that we're using. So today, for example, we'll be looking at let's say Amazon Web Service Lambda function. So their web page has a really up-to-date information about what it is, what can you do, what's the simplest example, and so on. We'll actually go through one of them. So let me just scroll down to just mention this part, which is today's objective is, I mean, we'll roughly follow these learning goals, but last time the goals were the following. Set up a Python environment. We'll kind of revisit that because there's heterogeneity of platforms here, but I will revisit that. We didn't start a Jupyter session last time, but we will do it this time. And be able to secure a web server. We just ran a web server, simple Flask thing running locally. But today we'll kind of spin up a virtual machine on Amazon. I mean, you can spin it up in multiple vendors, let you spin up a machine on their, I guess, platform. So we'll spin one machine up on AWS and then secure it so that other people can't get into it, only you can get to it. Okay. While doing so, we'll be talking about what does it mean in terms of just building blocks. Okay, we are not programmers, we are not software developers, but we need to know how do these things work at like a block level at least. Okay, and we did try to run a Flask app last time. We'll rerun it again this time because we're renting a new machine. We'll install Python there and run the same thing. Now it has a public URL. Anybody can go to that website and try predictions. Okay, and we'll again stick to simple regression or something like that. So that was the goals from last time. I know some of the goals were not met. We'll kind of cover it today. And today's goal, just a qualitative one, is just thinking about what is a managed solution versus what is not. I mean, here we're calling it hosted, but a managed solution, somebody else takes care of many things for you. Okay, it's like having a third party do a lot of things for you, like a managed vendor. So a managed solution, serverless solution is a managed solution. We'll see what it entails today. Okay, it's managed in the sense that you only focus on your business logic in your function. You don't care about installing Python, spinning up a virtual machine, anything like that. So that's the managed version. Okay. We're not really going to assess how much effort is needed. Obviously, there's more effort needed to spin up your own machine and install Python and whatnot. All the dependencies like Flask and other things. But we'll not really compare it, but you'll see the difference. Okay, you'll be able to kind of see the difference between doing the same thing with two different, I guess, setups. To do so, the serverless stuff, we'll just do a quick demo of both Cloud Functions and Lambda functions, which are just names. Okay, these are brand names for the one by Google and the one by Amazon, but they're just services where they abstract out everything else and you just focus on the function, right? So that's what we'll do. So that's the goal for today. So before I do that, I want to show the project examples. The folks online, you can hear me, right? If you have any questions, you should shout or put it on chat.
Okay, Professor.
So this is just a presentation. I'm not going to show the report. It's just I'm giving a sense of what was an example tool. You don't have to pick this tool or anything exactly like this. And also you don't have to pick exactly about deploying a machine learning model. Okay, it's just the basics that we're covering. MLOps involves many different things. But I'll just want to kind of give you a sense of what did this particular team do to give a sense of what tool they looked at and what did they try out, right? So in this particular tool, the tool's name is called CVAT. I think it's called Computer Vision Annotation Tool. So it's the same, I guess, organization which also has this very popular package called OpenCV. If you have tried, you can actually, if you can get the Python, Python package, which also interfaces OpenCV code, and you can actually get your webcam to stream to, and you can capture those frames and do many things like change colors, detect faces, whatnot. Okay, so that's the organization, and they have a open source tool called CVAT. There are also vendors who also pretty much do the same thing. Okay, in the sense of they also care about annotation of images, but this is an open source tool that the team looked at. So what did they present? Right, they're just for the presentation purpose, there's an extra thing for the presentation part, which is it's not extra, but it's a little bit different, which is you want to also tell your classmates like what is the tool about and why did they investigate and so on. So it's not exactly the same as what you do in the report, but it's more about informing the audience about, okay, this is a cool tool that we played with, and these are our findings or something like that, right? So that's what the presentation is. But you can imagine a report would be very similar, like how did you get installed? How did what were the kind of supporting things that you had to do to get it set up? Where does it set up? For example, for this tool, it's not always that every tool has to have an installation step or anything like that. So there's a little bit of difference, but much of the code is the same. Okay, this is what they investigated: the CVAT tool, It's mostly to put bounding boxes, or even that's not really a bounding box. You can see bounding boxes here. Let me move this chat window. Yeah, bounding boxes on the left side of this image, and then you have some segmentation. Okay, so like pixel level. Blue means that's part of the car, and not blue means probably not background. Right. So basically, they're telling what do you do, right? The software is installed on some system, generally like a desktop, and there are annotators who will open up the software and then keep annotating images. Okay? And this makes sense when you're not doing like a general purpose for when you can't use a ready-to-use pre-trained model. Okay, so for example, in language modeling, LLMs, you can use OpenAI's tools or Google's tools to kind of do many things. But if you're in a company and you have to annotate images, sometimes that domain of those images, for example, medical or something else, may not be the same as a general purpose tool that was pre-built for you, right? So you may have to do this annotation. And they're just talking about, this team was talking about, it turns out that the installation process involves spinning up what I call containers. We're going to talk about containers next session. But containers are just, again, something to do with spinning up servers. Okay, so very similar, but trying to kind of put a clear boundary between what programs you're running versus everything else in the system. So that's what containers do for portability and many other reasons. And so this is just a snapshot of some UI, which lets you see what containers you're running on your machine. Okay, so it's by a company called Docker. We'll get to this next time. I'm not telling you the details of this particular tool. I just want to give you a sense of what did they try. They're talking about installation, what challenges in the installation. This is some screenshots of their challenges. And then they're giving a walkthrough of how would a user use this tool, which is, I guess, the next few slides of to create some thing called a task, and then start importing images and adding labels. Okay, you can see some add labels and things like that here. Yeah, so this is once you get through like this setup of a project and all that, you'll get to some UI like this where you can actually put bounding boxes and things like that. Okay, so that's why they wanted to show that they were able to spin this up and try out what features this has. And this is a situation where there was no coding involved, right? I mean, this is like literally a package that's available, and they were able to run it on their system and just play with the UI. Okay, so that's not all projects are going to be like this without coding or without installation. There could be other aspects to the tool that you pick. Okay. So yeah, here we're mostly talking about different features. This particular tool has import, export, what types of annotations, things like that. So it's not very important for, except for the team that looked at it, that they should carefully look at what features it enables and what's actually useful and maybe related to their own prior experience. Okay, I think, yeah, they mentioned some other tools, something called RoboFlow, which is again, a third-party vendor, which lets you, use machine learning models. They're actually a managed service, which do exactly what we're trying to do in lecture 1 and lecture 2, which is they will host some models where you can send a feature vector or an image, and they will respond back with here are the boxes, here are the class labels, and so on. Okay, and yeah. So, and then they just talk about, I mean, for their tool, they talk about what is the advantage, what's the disadvantage. If, they didn't talk about across tools, they didn't try some other tools, like as I said, there are other tools that also do the same thing. Like if you're using Tableau, there's other, there's Power BI and something else, right? So you could probably contrast, for example. So here they just list some things. I think that's about it. So I do have another example, but they all follow similar format. So there's a tool-specific investigation of what did I learn? Is it easy to use? What features it has for a data scientist or a business analyst or somebody who's not, we're not developing the software. We just want to understand it's made for ML folks. So you want to kind of see where it can fit in your, in an organization's, requirements, right? Not all organizations need labeling. So if you have tabular data, probably no labeling. Text data, maybe you can spin up an LLM, a web service which can potentially label for you, or you can also have annotators. There actually used to be a lot of companies a couple of years ago. Even today they are, but I don't know, maybe not in the limelight, but which have lots of humans, under their organization and they rent those humans to annotate data for you in professional settings. Okay, and these are I'm not talking about small companies; these are big companies. So That's the annotation example to give a sense of what project is. So it's not too complex, but it cannot be also like very simple. And it also should not focus on any particular you know, thematic project. Like here, we're not talking about annotating like spatial images, or I mean, talking about annotating traffic data, or anything. We're not doing any analysis of the data itself. It's just about the tool. Okay. Any questions about this? Okay, so it's hopefully this kind of gives you a sense that it's not complex, but it is it's a fun project. You get to choose from the list, or you could choose something else, but you should just inform me beforehand and just get it checked what tool you want to try out. Yeah, so that's about that part, which is about project. If you have more questions, you can check in with me anytime during the class, after the class, or you can set up email appointments and figure it out. So we'll come back to what we tried last time. Okay, so we did. So last time there were two ways we installed Python. At least, I mean, one of the ways is using Anaconda distribution, which is one of the vendors which supplies these easy to use Python, I guess, executables for all popular platforms, Windows, Mac, and Linux. And the other way is if you already have Python installed, like on Mac and like Linux-based, many Linux machines already have it. So you can just create a virtual environment. Okay? And sometimes when you're trying to create a virtual environment, it'll tell you that some package is missing and you might have to install it. Okay, on Linux, for example. On Mac, there's also a popular, people of Mac might have heard of this before. There's something called Homebrew, a way to install packages. You can look into it. I mean, with Homebrew, you can also install Python. Homebrew. You can just type it here. They just say it's a missing package manager for Mac. But basically, with that, you can install a lot of different software. Okay? If you're not able to get like a nice installer, but if you already have Anaconda, that's fine. Okay, so we are not really doing anything. We're not going to kind of mess up your system. Okay, I mean, Anaconda was the maximum. I don't think you should be doing anything else exactly on your system. For folks who are using Windows subsystem for Linux, it's fine. Once you get into that prompt, you can do many things because you can always reset the whole thing. But otherwise, Python is the max amount of executable things that you're going to run on your own machine. Okay. Maybe next time we'll also install Docker desktop, but it's not necessary to have it on your local machine. But anyway, so Python is essential because it's good to have a scripting thing, and it's useful for your all other programs, all other courses as well. So have it running. So what we'll do, Mac. So last time, there's a reason why I used command line is because we're gonna log into a machine, and at least the initial part you have to kind of use command line. You don't have to, but nothing is like a set in stone. You can always have a UI when you rent a machine. Let's say Amazon, which we're gonna do it in a second. We can also rent a machine which kind of by default gives us a login window, and you can log in and whatnot. But at least the canonical or simplest way is to rent a machine which you can only access through command line, as in you will only have like a command prompt. And at least the initial setup, at least few steps you'll have to do via command. I mean, after that, for example, if you spin up Jupyter or something, you'll be able to have at least a browser, same experience that you've tried with Jupyter, which we'll also see today. Okay, so that's why we tried command line last time, just to give you a little bit of rationale of why do we have to learn all these, text way of kind of spinning up things. Okay. Yeah, let me get back to my notes. Okay, so actually, before I get into new content, I just want to briefly mention last time we had also, it's just a comment about Python. So I was in this folder called class, and if you recall, there's a new file, don't worry about that one, but there was a subfolder that we created called V and V. It's just a folder where all the Python installations specific to our project, which is the MLOps class, will be installed, so that it doesn't affect the rest of the system. Okay, so that's one way to create a virtual environment. But if you do it, if you have Anaconda installed, Anaconda also lets you create virtual environments through its own way, which is a little bit different from the Python, the way I showed you last time. So the last time what I showed you is Python minus M just means module, and V is the name of the module, and I can always say what is the folder name I want to have. So here's my environment. Okay, I can do this, and it will create a subfolder. So if I run this, just call it Python. Okay, doesn't matter. Okay, so if I run this, the command executed, and if I do an ls, which is a list of directories, you'll see the my environment subfolder got created. And to kind of instantiate that environment, and then do all your commands, pip install xyz, whatever you want, then you just do source source my environment and activate. So this is just a standard two-line command to get the environment, and you can see that now an extra prefix just came about. Now, if you see, like if you want to know if I'm going to do pip install, it's actually just restricted to this folder and not everywhere else. At least one weak indication of that is you can just say which. Which just means like which pip executable am I using, and it'll tell you that it's actually the one inside the my environment bin folder. So at least it'll say, okay, this is the executable is already also in this subfolder. If you delete the folder, this whole thing is gone. Okay, whatever you are trying out. So you have like at least a little bit of fail safe. Like if you feel like you messed up your Python installation or something, you can just delete that folder. Okay. So that's one way. So if you want to deactivate this, a symmetric command. I don't know. I guess I don't recall the. That's not the right command. Okay, let me just not worry about it. You can just close the terminal if you want to kind of get rid of that whatever environment you activated. So the second version is if you install Conda, and if Conda is on your path. Okay, so I know some people had an issue with executables being on the path. Path just means when you go to your command prompt, whether it's PowerShell or terminal on Mac or Linux, when you type something like ls and cd, the reason that they are just executables, okay, or programs. The programs need to be on some location so that the terminal knows that, oh, these are the programs we invoke, and so it runs those programs. Okay, Python is a program, ls is a program, cd is a program. All these are just programs. And when we type something, it just runs that executable. So Conda is on the path, and that's why I will be able to for example, I can check its version, right? So minus just happens to be, that's the way to kind of at least query Conda's version. Similarly, for example, I don't think Python is there. Okay, Python maps to 3.1 is a system Python, and you can see the Python version here, right? So we have Conda. All I'm trying to show is that Conda also has a, I think that's the command. So there's a couple of environments here, but you can ignore them. So you can actually create Conda create environment to also create a virtual environment. Okay, so and you can also specify Python version here. So the previous when we are doing it with Python, whatever your system Python version is, most likely you can't really change the system Python version. So if you saw that when I wrote Python minus version, it said 3.11 or something, right? So when I create my virtual environments, I'm kind of stuck with that Python version. In case you need to install older versions of Python or newer versions of Python, like there's 3.12 or 3.9 or something. So it depends on your problem. Okay. And by the way, these are not hypothetical problems. These are very realistic, that sometimes projects require different Python versions. So that Conda makes it a little bit easy. So you can specify which version to use, although I don't recall the exact invocation. Actually, I didn't try it. I forget the invocation. We can see if sorry, this is not the right command. Oh, let me just So we don't need this browser here. So let's, for temporary reasons, let's move it. Where will this template presentation be available on Blackboard is a question from somebody online. So about the project, sorry. I can add it to Blackboard, or actually I can just add it to this. It's just that it's a previous student's project, so I didn't wanna, but I can share it on Blackboard. And somebody else also has a question online. Bhavna? Okay.
No, Professor, I'm good. I just wanted to remind that there was a question in the chat, so.
Okay, so where's my okay, Conda create minus n means name, so you can put minus name if you want. Okay, or minus n, that's also the same thing. My Conda environment is just a new environment name that I'm giving, and then you can say I want Python 3.9. Okay, so this will create a new environment very similar to the virtual environment that we created. Okay, so it may take some time, and it may ask you these interactive prompts. You can get rid of these interactive prompts also by adding an extra -y or something. But let's say we installed, we got this virtual environment. Okay, so we have this virtual environment. Now we can just activate it. Conda activate my Conda n, right? I think there is an issue with the yeah, I think I'm having an issue with the path. This is this is what I said. So activate is not found. So for this Conda version, so I'll just check online what the invocation is. I mean, these are version upgrade issues, right? So older version of Conda might have activate as a keyword, and newer version they'll change the keyword. So I'll check in the break and let you know. But I didn't want to kind of derail. So it's just two ways to kind of create restricted environment so that you don't have to worry about it affecting the rest of the system. It's very important because otherwise if you mess up a lot of other things of the system, then you'll have to potentially reinstall your whole operating system. Okay, so anyway, so Conda and basic Python. Now, what I want to do is, and also WSL2. So hopefully people tried out getting WSL2 enabled. You just have to kind of choose, some operating system like Ubuntu or something as a default operating system. And once you have that, it will be the same commands. Otherwise, PowerShell has a little bit different set of commands to run. Okay, so what we want to do now is let's actually spin up a machine, a remote machine on any vendor. We'll use AWS, but just to kind of talk about some security aspects. Okay, it's just a minor detail, but still it's important that anytime you go away from your own local machine, you kind of at least have security as an important aspect to think about, right? So where did I? Yeah, I'm just sorry, that's not relevant. So actually, I do have a. I'm already on the. This is very sensitive. So let me actually go back to. Let me just go back to this website. So you'll have to create an account. So I'm not showing the create account and login process, but you can create an account. Generally, you probably need a credit card. For the first year, if you're creating a fresh account for the first year, you can use some of these services for free. Okay. In fact, you can spin up you can rent a machine for free for about a year. So it's a great deal for people who have not created an account. If you already created an account, it's still okay. Like today, I'm not I've created this account probably 2 years ago, but it doesn't cost much and it's a good learning experience. Okay? So once you log in, this is, I guess, the default page where it'll just say, okay, you have some region of interest where you will be. Here for me, so and you can see that that's my account, I guess, login, and it says some default region. Okay, and for you, it may be different. There are so many places in the US or elsewhere. This is mostly about where you're renting the machine from. You should probably not rent a machine which is like too far away from where you're physically located, in case there's latency of sending information there and bringing information back. I'm at some default location, and so there are like lots of services, and there's also a great project idea for also, which is to look at what services are related to machine learning. So if you look at machine learning and AI, there are like at least 20 services that are listed here in production. And I'm sure those people at AWS are also building like 20 more services to be launched maybe this year. But you can look at like what they are and maybe investigate, how to use them, what's the use case, how to get them running, some small code examples. So that's up to you. But let me come back and say that among services, there are a lot of services, but we will just look at for today. Yeah. Which one of those among those 20, you can, as long as it makes sense, right? So yeah, you can, but they might cost money in the sense that you need to have a little small budget to investigate them. Yeah, you can choose. For example, there's something on OCR that some team did earlier. OCR means like detecting things on a receipt or something, right? To extract those numbers and text. Yeah. So some people have looked at it before. Actually, it's right here. It's called extract text from virtually any document. It's the fourth or third one. Anyway, so all I'm saying is for today, we'll only look at one, renting a machine. That will quickly do that. It's called EC2. Elastic Compute is, I guess, the name for that acronym. So on EC2, we can just create an instance. Instance is the virtual machine. Okay, there are a lot of things happening on these UIs, and it takes some time to absorb it. And I know I'm gonna go a little bit faster. I mean, in the sense that you can say, okay, what are all these 100 different things happening? It's good to investigate like what does each mean. Each vendor has their own way of organizing what services they sell, right? So here, Amazon has a certain way of organizing their stuff that you can do something with, like rent a machine. That's what we want to do, right? So we'll just use a UI, and as I said, like the multiple ways to achieve the same thing, like Python installation, the way I did it is probably not the exact way you would do it. You could probably double click and get something running. Similarly here, you can also rent a machine programmatically, as in through the command line, okay? But we're not going to do that. We just want to rent something and then talk about security and Python in that context, okay? So let's, actually, you don't need to go there, but if you are on the instances tab, then on the top right, there is a launch instances button, right? So you can give any name here. Let's call it MLOps 2024. So there are some fields where it'll tell you that some necessary these are necessary fields, and it will not let you move forward. Generally, the vendor does a good job of choosing defaults that are pretty secure already, and I'll point that out, at least for this vendor. Okay. So the next thing you need to choose is, okay, which operating system, and you can see that actually Windows and Mac as well here that you can run. But we'll just predominantly most web servers run Linux or some variation of Linux. You can choose Amazon Linux if you want, which is the default. If you just click, Amazon Linux is the tile that is default chosen. I'm just choosing Ubuntu. Okay? It's just it's slightly different flavor, and there are others also. And it can actually, it shows here for those who freshly created this machine. Yeah. How are these? So many of the websites, almost all websites kind of run on Linux. It's Linux-based operating systems. Mac and Windows kind of recent. Windows also, obviously, there's IIS server and some other technologies which let you serve pages or web apps and so on. Which one to choose really depends on, it needs more in-depth understanding of what's your specific use case. I think there's in broad, today we're just doing an extremely basic thing of setting up a machine. That's why we're just choosing something simple. So yeah, the short answer is you need some analysis to figure out which one you want. Yeah.
So if we are like doing this, then like are we setting up this thing in the data center?
Yeah. Oh, okay. So what we are renting is a virtual machine. So I think last time I briefly mentioned, or might not have mentioned that, I don't know if in detail, but a virtual machine is just they're not like, they already have physical hard disks and CPUs and RAMs lying around. Okay. And also, there's a lower level software that's running on them. Anytime there's a request comes in to like spin up a virtual machine, like I'm asking, on that software provisions a little bit of compute, which means CPUs, some amount of RAM and some amount of hard disk. Yeah, you just rent it. And so from our perspective, it looks like a full-fledged machine, but it's actually virtualized in the sense it's not running directly on like a laptop or a desktop machine in their data center. It's running on some software, but it is in their data center. And the data center is actually, I didn't explicitly mention that that's the data center. North Virginia data center is where my account is just defaulted there, but you could choose something else. But that in that data center, we are invoking a virtual machine. Yeah. So let's just choose Ubuntu, and you at least fresh people who just create an account, it says free tier eligible. So if you keep things to be free tier eligible, it's not going to bill you anything. And you'll see that we're not going to choose anything complicated here or anything expensive. So at most, if you keep running like a machine like this, which has, so sorry, this is just the operating system choice, which is free. If you choose Windows and something else, then it may not be free. Okay, because Windows has a license, Mac has a license. And you can choose keep everything default. In terms of this is the hardware part. Okay, so what hardware does a virtualized machine need? You can see there are a lot of names here, but we just need to focus on a couple of things for today. How much of CPU and how much of RAM? Okay, so those are the two names there. One vCPU. vCPU means virtual CPU, and 1 GB of RAM. Okay, this is a little bit standardized across vendors. So other vendors will also kind of quote you prices based on how much CPU and how much RAM. Okay, the more you want, the more costlier it will be. And what we're actually getting is also called as on-demand instance. Okay, so it's just we want an instance, and that's why we're getting it. There are variations like reserved instances where a company will say, "Oh, for the next 3 years, I want 10 machines." Okay, that's like you're making a reservation for 3 years, and you might get a discount because the vendor is happy that somebody is like renting something for them for a longer term. Okay. So it'll show you other prices if you want to kind of get a sense. But this is just a one-time thing. Generally, in large organizations, there's probably a small team of cost and billing optimization folks or not just cost and billing, but also AWS solution architects on the AWS side will also help you kind of figure out what's the right thing for your organization. So we're not in that setting. Let's just choose the default. So this is the important part about security. Okay, so so what have we done? Chosen operating system, chosen a machine, which is just default, so we didn't really choose anything. This key pair is an important concept that I'm going to discuss. It's related to secure shell access. Okay, SSH protocol. So this key pair is exactly what it means. There's a key and a lock. Okay, and the lock will be on the machine, and anybody who has this key can enter that machine. Okay, so that's literally how it kind of visually you think of. And so for this new machine that we're trying to rent, we're going to create this lock key pair. Okay, so key and a lock pair. So let's create a new key pair and just MLOps. Let's call it. Yeah, it doesn't matter. I didn't, name is not super important. So you can choose, I mean, these choices are not super important. Let's choose something, it doesn't matter. Like those are just encryption technologies. It's not important. The next step is probably useful for Windows folks who want to connect to the remote machine, there is a popular tool called PUTTY. Okay, it's kind of a, it's before Windows Subsystem for Linux 2 evolution. So with WSL, you can actually don't need PUTTY, but in case you just wanted to not worry about WSL and all that, and just wanted a way to access this remote machine, you can install that PUTTY, and it expects a different file format. Okay, that's called .ppk file. It's just like a file name extension .txt. It's just called .ppk. Let's keep it. I'm not going to do that because I'm not on Windows, so I'll just choose the default. Okay, which is called a .pem file. These file names, don't worry about it. All we're doing right now is just creating that key lock pair. Okay. Let's create the pair, and it just downloaded it by default. So that's the what I got. It downloaded, although it's called a pair. I only got the key. Okay, that's this PM file, and you should not share it. Okay, don't put it on GitHub or don't put it on your website or something. Okay, you can share it once you destroy your machine if you want to, but the machine has the corresponding lock, okay, which lets you enter into that machine using this key. Okay, so yeah, we did that. So after that, it said, okay, I mean, once it gets auto downloaded, it just shows what we just created that key pair. So that's the name here, MLOps_2024. Then network settings, let's keep, this is also important on security aspect, which is that, which is, the security group and stuff, it's vendor specific. I'm not getting into too many details here, but you can see that what type of connections can be made to this machine that we are renting. Okay, that's the question here. And you can see 3 popular types of connections you can make. One is SSH. That's the one that this vendor AWS is letting you, is saying, okay, let's default check that in, because at least you need to enter that machine through some way. SSH is that secure shell, protocol. That's the one which uses this key to get in. Okay. The other 2 are HTTP and HTTPS. That's like, websites, right? If you go to google.com, you'll have one of these strings of the prefix. So we don't need them. Okay. If you want to host a website, like your own website, then you might need to keep that open. Okay. It also tells you that right now anybody can access this machine because of the some choice here, which is the 0.0.0.0. If you recall, last time there was a similar string like 127.0.0.1 that corresponds to our own local machine. But most machines on the internet are accessible through, if they're accessible through this internet protocol IP. Okay, IPv4 version 4 requires all machines to be addressable by these numbers, which are separated by these 3 dots. Okay, these 4 set of numbers, and the numbers are between 0 to 255. Okay, and they are basically the address. It's like going to 601 South Morgan Street or something. So it's the address of that machine. Okay, so currently, apparently this is my IP. So Amazon detected that what our UIC IP is, and it's saying, okay, if you only want to connect from UIC, then choose this last option. If you want to connect from anywhere, like let's say you're traveling all over the world but want to connect the same machine, then you should keep it open. Okay, but again, this is not secure, and that's why it's saying that anybody else can try to access. They may have the wrong keys, but they may try to access your machine. Okay, which they will fail, but they can try all sorts of keys. Maybe they can keep guessing, and maybe they get the right key. It's not possible. That's the whole point of cryptography here, with some choice we made earlier. So people should not be able to guess the key. It's just a bunch of numbers, a bunch of whatever text, and enter your machine. Okay? Otherwise, the internet would be very insecure. Okay. That's it. And then storage. I mean, the only thing we did not specify earlier was we specified RAM and CPU. What's the disk space? By default, it says, okay, 8 GB, which is not much. Let me just change it to 28 or something temporarily, but some hard disk, okay, that's needed for the machine. And that's it. So okay, let's start this. So it got provisioned. So these really big companies have have really good software behind the scenes to kind of spin up a machine quickly. Or at least it said it's instantiated, and so instance is still, it's getting created. So it says pending here, right? So, yeah, let it get started. Okay, it's like literally starting a machine computer, right? So in the meantime, we look at how did I get this? Again, instances tab, there'll be one row corresponding to the one machine that you spun up. And the bottom part is just because we chose that, okay, it's tick mark. That's why the bottom part information popped up. Okay. You should try this out, create an Amazon account and try this out because it's free. I mean, everything you will be seeing that it's free trial eligible, then it will not cost you money, at least for 12 months, 1 full year, right? You can also, and by the way, if you want to kill that thing, you don't want to, you want to delete that machine, then you should go and terminate that instance. Okay. Don't just shut down, because shutdown will also cost money. But if you shut down, means at least it's secure in the sense that other people can't enter it. But if you really want to get rid of that instance, you just do terminate. Okay. For now, here's the public IP address I got. This is the address. Okay. So I got instantiated. So Amazon, in this case, happens to own a bunch of these addresses that will assign to whenever the customer requests machines, they'll give that one of the addresses to that machine when they spin up something for you. Okay. So there's a lot of things behind the scenes that happens to get us a machine that is we can talk to. Okay. So this is the IP address. Okay, and still says it's running. So that's the IP address that we're gonna use. But let's look at security for a second. Yeah. So security, and I'm just going to focus on one thing. So I just went to the security tab, like there were tabs at the top, right? Top of this pane, like there are details, status, monitoring, security. On security, you will see the inbound rules here. That's exactly what we chose. So you can, it's basically saying anybody can talk to this machine at that IP address that's public. People can literally know that, okay, there's an Amazon machine there. But when you talk to programs on those machines, the programs only talk in terms of port numbers. Okay, there will be programs listening to certain ports. Like last time when we spun up our Flask app, Flask program, it was only listening to the 5000 port. Okay, so programs, you can think of programs are only listening to incoming requests at a single port of this address. Okay, and so at port 22, we will see that there's going to be a program in our virtual machine that's going to be listening to incoming requests to log in, okay, as through SSH. Okay, and right now we're saying anybody can, from any location, you can log in. You can restrict this to UIC only or something like that. So you can edit this part, not just edit this part in the sense that this one row, if you want to do like a web server, if you want to have an HTTP website, it says, okay, yourname.com or some your ML prediction model.com, then you might have to open other ports, okay, other ports like 8080 and so on. So there are some default choices here. It's not too deep, but all I'm saying is there's a machine that we spun up. Currently, there should be a program on that side listening to anybody who wants to enter with the key that only I have to this port 2020 through this port 2022. Okay. So let's. It still says pending. Let me just refresh this and see if changed. Okay, it says it's running. Okay, let me move that. I'm just moving it here so that I have the MLOps, the key that I have. It's just text, okay. So what I can do is so SSH is again a program very similar to CD, LS, what else, Git, whatnot. So SSH -I just means identity file, so which is the key file, the key that I have. I can do /MLOps underscore that PEM file that I downloaded, and then since we installed Ubuntu, then we just type Ubuntu, and sorry, I'm just trying to see what the okay, that's the IP address that I copied from that website. So if I press enter first time, it'll say, okay, I mean, first of all, your client, your machine is asking, hey, do you think that's a rogue machine or is it actually legit? So let's say it is the correct one. So it did not let me log in. Okay? So this is the first hiccup sometimes you'll have, which is that you may have to change the file permissions. That the key file that we have, that key file currently by default, it's viewable and readable by anybody else who has access to your laptop. Like think of on your laptop, you have user names, right? So you are user Teja, and if some other user is also there, they may also be able to read that file, and that's not something that SSH protocol likes. So the way you can change it is to do chmod is the name of another program. I mean, I'm just doing it by command line. You can just do right click and also disable read write permissions for other people on both Mac and Windows. Okay. So I'm gonna do. Don't worry about this number 600. It just means only I can read, only I can write, and nobody else can read, nobody else can write. Okay. Of this file, MLOps 2024, and then I can re-execute that command. Okay. Let me just clear all this. Okay, that's the command that we ran last time. So now we should be able to enter. So now you can see at the bottom, it says Ubuntu at some other location. Okay, so now we are in that remote machine. So we were able to at least do SSH into that machine. Okay, so by default, this machine is already, I mean, not by default, but thanks to the way this vendor, AWS, sets it up, only port 22 is open. It's already secure. Only this key file lets you enter the machine. Okay, so that's pretty restrictive. So the question is, what else can you do, right? So a couple of things you can do. Obviously, we can install Python there. Actually, you can check that there is a system Python version. There's a system Python version 3.10 already there. So which is different from, I think, my machine at 3.11, right? So there's already a differences here. So we have Python already there. Let me see what I want to show. Yeah, so there are two things we can do. One is spin up Jupyter there and remotely log into Jupyter securely. Remotely use the Jupyter that's running on that remote machine, as if you're kind of running on a Jupyter instance locally. Okay, so so we can do that, or we can use our ID to directly connect to this remote machine, and without Jupyter and stuff, you can directly do coding. Okay, so those are two pathways. Let's see. Yeah. So just to recap, I mean, we went through some, user interface of AWS and so on. The most important thing I wanted to take away from here is we were able to rent a machine, we logged in, but the important thing is the security aspect that we chose. I mean, by default, thankfully, thanks to the vendor, we were able to have only, if you don't have the key, you can't log into this machine. Okay, like you know the IP address, not this one, but like on the other page, you will not be able to log in. So that's the important thing. Now, what we can do, there's more security things that you can do, but I will not, we'll not get into that, which is you can put a firewall. I don't know if you've heard of, I mean, on Mac, for example, there's a firewall, right? It'll say firewall triggered or something, or even on Windows, right? So you can put a blocker on your end, which is running on your machine instead of some setting choice on the AWS side. That can also let certain traffic means certain interactions, certain ports be open to the world or not. Okay. So if you're interested in firewalls and stuff, we can talk about it offline. Okay. We'll not do that here. So with that, what we can do is run our Flask app, and what we did last time, we did it on local machine. Let's run it on a remote machine just to get a feel for, oh yeah, we are able to deploy something on a public cloud. Okay, public cloud instance. Okay, so for that we just need to quickly git clone and let me see, where's the This is not. So you can I'm not sure if I can do git. Let's just see. That key that we created, that's only kind of useful for that Amazon machine. But if you wanted a key pair, which you can use for other services, like GitHub also lets you put a lock on its side, and you can keep the key, and you can also do Git commands. You can have your own like programmatic access instead of UI-based access to GitHub as well. But we'll not do that. So okay, first of all, Git may not Git, yeah. Git is installed here. So git clone that link. Okay. Now, last time we did right. So first time, for example, this default Python and this operating system did not have the virtual and package. So you can just follow whatever it says, right? So you can say apt install sudo is like root access, so you run as an administrator equivalent. Is that wrong? I'm just updating the list of packages it has, and then okay. So I just ran the V package. I'm just going to install it. You can. And if you have trouble with this virtual machine, because all the commands for everybody will be the same for this type of machine, so hopefully there will be less of confusion of different operating systems and stuff. So if you have if you are stuck with anything, watch the recording or let me know. Actually, there's a question. Oh, is there still a question, Bhavana?
No, Professor, there's no question from my end.
Yeah, so create a virtual environment. Okay, source. Okay, pip install Flask. I think Flask was needed last time. Okay. Was this runnable? I don't know. So let's try. Okay, so we just went into that folder and we ran the same script that we tried last time, right? So you can see it's saying I'm running at some IP address, those 4 numbers separated by 3 dots and a port. Okay, but from outside world we can't access this port. Okay, that's how we have set up on the AWS config. So there's one change we need to do, and it says Control-C to quit. So let's stop that. So let's do. So here app.run is the last line here, at the very bottom of the screen. You type host is equal to 0.0.0.0 so that anybody can access this machine. And you can also change the port if you want, like comma port is equal to 8080. Okay. And right and quit. So what did I use to edit that? Right. So I used a program called Vim, which is I guess more restricted editor. I'll actually in 2 minutes, I'll show you how to do it with your IDE VS Code. And that will be easier, much easier than editing like this. But I wanted to at least get the app running first. So now it's saying that it's running on all addresses, and it just means that, as long as somebody can access this public IP, like the 50 something that we'll access in a second, as long as they can get to 8080, then they'll be able to see what the app is doing. Okay, I mean, in the sense that they'll be able to make a request to this app and get back a prediction, right? So the only challenge is now how to get 8080 enabled. We just have to go back to the prompt and sorry, I think yeah. Go back here, and then we'll change the inbound rule to 8080. Okay, so we'll just click on, this is our instance that we just created. Click on it. Sorry, go to security, or I guess networking is also fine, but you can just go to this clickable URL, which is a long, bunch of alphanumeric characters. It'll tell you what the inbound rules are, so you can just edit the inbound rule. Okay, so right now it's only SSH. I mean, it says its type is SSH, but let's edit it by adding a rule. You can say custom, or you can just say, I don't know, HTTP. Actually, that's not the code. So let's just say custom TCP. So let's not worry about what these acronyms mean. These are actually, different specifications of protocols that let computers talk to each other. So TCP builds on this IP protocol to address things and keep information, like keep sessions and stuff like that. It's a lower level detail, so we'll not worry about it. So 8080, and for now, let's say anybody can access it. This particular Flask server, which is, by the way, a bad idea to have a Flask server, which is not a production system. It also shows you when you run Flask app, it says it's only for development, do something else, right? But to get extreme basic minimal thing running, we can just do this. Yeah, and then just save the rules. Save it. Oh no, this is not. Okay, we save the rules, and now we can go back to that machine. And just go to that IP address that we have. Okay, so let's again see the IP address here. Let's see what the So you are able to access that Flask app, right? So you can see that because we opened that port, now that app is listening at that location and it's publicly accessible. Okay, you can actually now make it a little bit more, like if you want to make things secure at the app level, you can ask for a secret key from any client that tries to access your app. So you can do many things at different levels to enhance security of your thing. Okay. So you can look up Flask documentation. We didn't open Flask. That's the only documentation that we did not see. But for others, we'll see the documentation. Like today, we have 2 more short things to see, which is cloud functions and Lambda functions. We'll just go through the documentation. But for Flask, if you go through the documentation, it will tell you how to have a secret key so that you don't entertain random requests. I mean, only people who have a key can make a request. So that's beyond the SSH thing. SSH is just to get into the machine. That's one program running at port 22. There's another program running at port 8080, which is a Flask app, which can have its own, right now it's anybody can make a request, right? So we saw last time how to make a request, like $XS10 or something. Yeah. So you can make a GET request to this. GET is a specific type of making a request, right? And HTTP protocol. So anybody can make it. So you guys can make, as long as you remember the IP address, you can make a request. So that's if you want to restrict that, you can add restrictions at the app level also. Okay. So this is just running a program, and you can keep running the program. So how do you keep running the program? Right now, the way we have instantiated it, we have to, if we close our terminal and close the laptop, it's going to stop running. Okay. So one simple way to do that, so I'll have to stop it. is to use the command called nohup. It's just a command that's available in this operating system, which lets programs run forever. Okay. Another way to do it is to use a program called screen. It's not installed by default. I guess it's installed by default. So screen is another program very similar to nohup, which lets you create a terminal within a terminal, so that if you close your machine, that terminal is running. Okay. So it's a bit it's like one step detaching where you're running the program. So right now, for example, if I exit the session, it says you logged out from that machine. Okay, remember that's the machine that we rented. So let's log back in using this SSH protocol program, and we'll get back into this thing. So this terminal, if you close our laptop, it's gonna, things will stop. Okay. So what we can do is type screen first, which, there'll be some information shown, and then what happened is now this prompt is actually one step removed. Okay, so here if you run something, and if you also, you need to exit the screen session, which is Control-A-D, and then you can close the laptop and the program is continue to run. Okay, so we'll not do that right now. That that's just a detail, but I just wanted to mention that if you want long-running programs, there's ways to do it. Nohup is one command, and screen is another command to. There's also tmux. So there are many ways to kind of run programs permanently. Okay, not just those. There are other ways to run programs permanently. Okay, for example, the program that's waiting for you to give your key so that it validates that you are the right person. There's a program running 24/7, right? So that program, the program was able to be set up as a long-running program by the operating system. Okay. So anyway, so what we'll do next is I will not. Yeah, okay, let's try a couple of things. I want to get to the serverless in a second. And this clock is not running. Okay, so let's do the serverless components first, and then I'll show you how to connect your IDE to this machine, so that you can always have a machine. Your IDE, I mean, specifically, I'm talking about VS Code. I think last time I showed you that's a great integrated development environment for writing Python programs. It's very useful to use it, get used to using it. And so we'll see how to use that to connect to this remote machine, so that you don't have to do you don't have any install things on your local machine to do anything. Okay, all the Python related programming and running of scripts, everything can run on this machine. Okay, so we'll do that. But before that, before everybody gets exhausted, I want to talk about serverless programs. Okay, serverless managed services. So we did a lot of work, right? The past hour or so, we did a lot of work just to get a machine running and a simple Flask app running. And I was talking about security, but whatever we do is going to be worse than getting the serverless managed service, because the guys who built that, whether it's Google or Amazon or anybody else, okay, there are many sub vendors for this. They have whole teams of engineers who take care of security, reliability, scaling, many different things. Okay. Whereas us renting a single machine with one CPU, vCPU, and 8 GB of RAM or whatever it is, 1 GB of RAM, it's we have to constantly think of, oh, if we have 10 users, how much should be the thing? Or do we have to spin it down and again spin it back up? Do we have to go through all these installation steps? There are many ways to automate all this, but serverless is a great bullet point for people who don't care about all this. The business, if their core business is not about cost savings at this level, maybe the personnel or like data scientists are much more expensive than getting a managed service and spinning up resources, then you should do that, right? So let's try. I have so many tabs open here. Let me go back here. Signed out. Okay. So first we'll try out a serverless function. So it's how did I get here? You can just, for EC2 and whatever I'm going to show now, you can just search on the search bar. Okay, so you can just search for EC2 and you can what services it offers, you can find it, right? I mean, this vendor has too many services, so that's why it's, I have a search bar and many other ways to get to that same service. So instead, we'll use something called Lambda. So I mean, I guess the phrase says run code without thinking about servers, right? So it's really on the other end of the spectrum, where you don't care about what machine, what operating system. You do care about, for example, if my program uses Python 3.12 features, then maybe Python 3.6 is not the right runtime environment. But other than that, you don't really care about what machine, you do care about some things like authentication at the app level, but otherwise SSH and stuff is not there. Okay. So currently I do have a function running, but it says here, for example, it says Node.js app, but let's not worry about that. Okay. So this is going to be the fastest kind of tutorial. I'm not showing the tutorial page because it just shows the same thing of what we're doing now. And it's going to be just 3 steps. Okay. But you'll get a feel for how to host a function. This is the business logic. And then you can kind of think about, oh, what if my business logic is complicated? What if it needs extra files like some TXT file or a CSV file to show some extra things? You can start thinking about it. But in terms of mechanics, let me just show one. Oh, I don't have the slides open. I just wanted to show one slide before we get into the 3 steps. So yeah, last time we stopped at slide 6, and there are some names here. We didn't use all of them, but that's fine. I mean, okay. So what are we doing now? It's exactly the same client server protocol. Just recap. This is what we did last time locally, where both the client and the server were running on the same machine. Today, what we did is put the server on a rented machine. Okay, and it's publicly accessible, right? So so we are still doing this. Now what we'll do is do the same thing. So there's still a client piece is the same. You make a GET request, you make a POST request. The different types of requests, and we'll see some request types later on perhaps. What we're doing now is really taking advantage of managed service such that you just focus on the core piece of your service, which is, for example, in our case, we want to serve a prediction model, right? So the prediction model, really at the essence of it is a bunch of weights of a model, and the weights of the model interact with the feature vector coordinates, whatever numbers or whatever other things, and then you spit out a class label or a number, right? That's it, right? That's your core logic. Everything else is kind of just, is tangential, right? So what you do is basically let the service, in this case, service provider, in this case, Amazon, take care of many different things: security, scale, resiliency. Resiliency just means fallback if the machine fails, for example. Like think of a hard disk failing or something like that, right? So those things are completely ignorable because the vendor gives you what is called a service level agreement of they will be having certain uptime. If you run your software on their whatever infrastructure, they'll say, okay, we'll, for a whole year, we'll only be down at most 5 minutes, okay, if at all. Okay, that's the type of guarantee that they will provide. And so given all that, what you need to just configure is your function. Just focus on your function. In our case, our Python function, and also a way to talk to this function. That's where, again, the way to talk to will be HTTP protocol. But you can make it, as I said, a little bit complex by saying, okay, authentication is needed, or restricted geographically and things like that. So you can do many different things, but we'll not do all that. We'll just set up a function and set up this gateway to kind of trigger that function. It's very similar to Flask routing, where if a root / process or / my prediction comes, then some function gets invoked. That's very similar to, we're doing exactly the same here. Okay. So with that, let me come back to Lambda. Let's create a function. by default, I mean, you will see maybe a different interface, but there'll be a big block button saying, okay, create a function, right? Again, this is pretty cheap. Actually, it's free for up to 1 million requests per month or per year, I don't recall, but there's a lot of, it's part of free tier, okay? So we'll just follow from scratch, although they have some other more complex options. Just give some function name. And here we'll choose some runtime. For us, I guess it's Python. So you can see only these 4 are supported. So if you have an app which requires Python 3.112 or 3.12 features, maybe specific to 3.12, then you can't use this. Okay. Or you have to do something elaborate, some third option that you saw at the top, containers or something. So let's just choose some Python because we're not gonna worry about that. And yeah, so you can just create a function. Okay, so what it does is gives you a very quick starter code so that you can just quickly see what the function, how your setup looks like. Okay, so all we did is just choose a Python environment so far in the previous page, right? So that leads you to the second page where it'll show some in terms of some block diagram of what are the moving pieces. Okay, there is generally these cloud functions or Lambda functions. They generally tend to be intermediaries in large software whatever architectures. By which I mean, for example, they can get triggered by some client, like from a browser. I can say, hey, make some function run. Okay. And that function can say, okay, let me pick up some data from National Weather Service and put that data in a database, okay, Postgres database. So that could be destination. So all I'm saying is these are like generally small, really lightweight servers, which can be triggered to do something, and they themselves will reach out and do other things. You can set it up that way, and that's generally the use case. Okay? Or you can also set up this as a way to serve your websites also, or prediction models. And so that's just a block diagram here. But you can see the interface really, let me just close this, is very simple. So it's actually giving you a code editor right there. So it's just saying, this is a folder, MLOps demo function folder. It just has one py file called lambda function.py, and that's this function here. Okay? It's just literally saying def lambda handler. It has 2 arguments, event and context, and it's just saying return saying hello from lambda. So it's not even using its arguments currently, but there's ways to use it. And we have an example lambda function folder or script in our code examples repository. You can just change and copy paste here. But so this is pretty much it, and it's importing a package called JSON. Okay. So what you can do is right now you can't invoke this function. So what we'll do is the second step, the trigger part, we'll just create the trigger, and then you'll be able to invoke this function. And then you can keep adapting it. You can just focus on your business logic, change it. Maybe it errors out. You can look at the logs, fix it. Okay. So let's add a trigger. Select a source. There actually, this is a pretty, this vendor has too many services. So let's focus on one source. So let's choose the second one, API gateway. API just stands for application programming interface. But it's just a block which can trigger your function block. Okay. So let's choose that API gateway. Let's just say create a new API gateway. And so basically what it's saying is, what are we trying to do here, right? It creates a surface from which you can make a request, HTTP request. Endpoint just means like a place where you can make a request, and that invokes this function, and that's it. Okay, that's all it's doing. This is just an intermediary, which, for example, gives you a static IP address or basically some sort of address where you can make a request and that triggers that function. That's all. So in the previous slide or previous, I guess, page, all we did is create the function. We didn't really attach it to any way to kind of address or something so that it can be invoked. That's all, right? So let's call it HTTP API. I mean, there are choices here and you can read more. And for now, security, we're going to just keep it open. Okay. This JWT, I guess JavaScript web token or something, that's a way to authenticate so that you're not like, and not everybody can trigger that function. Okay. But for us, we'll just keep it open and then just add that. Okay, so all it's doing is instantiating this API gateway. This block was not there in the bottom left API gateway. It's now there. And actually, that's pretty much it to get a function running. And after that, all you need to focus is on security, which is the authentication piece, and then your business logic. Business logic will be in that. It's a single function, but you can imagine like creating many helper functions that can be invoked from that single function, right? So, so this is the location. It just says hello from Lambda, but you can change it, right? So hello from MLOps code, and you can change that to our regression model also. Regression model doesn't have any other dependencies. It just has just a model, and it's just looking for a get request with X as an input and can just respond back. We can do that. Okay, so this is without Flask. Here you're only looking at the function, and the service provider is taking care of the Flask type features that are needed for you to be able to serve your model. Okay. Any questions here? I don't want to make it more complicated than this. Once you understand these are two building blocks, you can really improve them yourself, right? So you know how to write extra statements as needed for your use case. No questions? Okay, then I want to quickly show the Google version also. It's the same thing, but I wanted to quickly show that and then take a break, okay, at 8 minutes or so. So let's see, where's the Google part? Okay. So, very similar to AWS, you can go to Google Cloud and create an account. They also have, I think, they have some different way to give you free resources. I think they give you a $300 credit that you can use for resources, and it's plenty. Okay, I mean, these cloud functions, by the way, as I said, up to 1 million invocations are free, or at least they foot the cost. So at least cloud functions you can definitely try out without any issues. Okay. And you can also try out VMs also, the virtual machines that we invoked last time with AWS. You can get it from Google Cloud also, and it's going to be free for a certain period. Okay. So here I am on Google Cloud, and this is just a starting page. Generally, Google has a little bit different organization, just like Amazon has like so many buttons for setting up or different things. Google also has something different. Okay, and it's we will not have the time to go through all that user interface. We just want to get to our serverless managed service, right? So I think I already typed it here. So one step you need to do before is to create a notion of a project. In Google Cloud, everything is like a project, okay? Just like our virtual environments, like you can have a lot of resources that you will invoke in a project, and if you delete the project, essentially you can get rid of all those resources, okay? So, and I created a project called MLOps right before, but you can create another project. I don't want to, so I can create another new project here at the top. Right here, but I'm not going to do that because it's just it just creates another name there, and then we can directly get to Cloud Function. Okay, before I quickly get to Cloud Functions, you can again see that if you type virtual machines, sorry, not machine, you can see maybe not there. You can also see that there's going to be a lot of services related to machine learning. Actually, you can see that there is a maybe not in the first list, but okay, this is still going through the list of a lot of things, networking, operations, other things, analytics, right? So this is just data related, many of the things that you see in big data course and stuff like that. And then you have artificial intelligence as a huge subtopic where there's at least, seems like at least 10 plus managed services, very similar to AWS. So you can actually, pick one of these if you want, but do a due diligence of like how, whether you can play around with it or not. Sometimes they are so many, sometimes they are like, there's a contact sales button and stuff, you actually doing something self-serve. But if you want to play around and investigate, these are services that companies use, right? So any company whose core product is not specifically building the models themselves, but actually providing some services, they might actually just rely on these. Okay, not just these, but there are many vendors here. So, for example, Vertex AI is one of the tools that some team tried out, in one of the previous offerings. Okay. So let me actually just come back to cloud functions. So very similar interface. I guess some cloud functions already running here, but you can just create a function very similar to that previous. There is going to be some differences. I'm not highlighting the differences from Amazon to Google, but it's very similar. In this case, it's already telling you how to trigger this function. So you can say at the time of creating the function, you can say I want to trigger it using, let's just keep it HTTPS. But I can allow unauthenticated invocations. Okay. I can say, okay, just anybody can trigger it. And I did not even change the default function name. It's just function2. And then next. And then here's the list of environments, right? So it's very similar to the other vendor. In this case, this vendor has 3.12. Okay. But okay. 3.12 code for Python looks longer, but this is how, so it's a little bit different from the previous vendor, but here you have a main.py where you do a bunch of imports, add a decorator. I think I mentioned it to you last time as well. Flask works with decorators. Decorators are just function wrappers. Okay. And then you have the function that you can define, which takes requests, very similar to the Flask app. Flask app had a request.get, search for whether feature vectors was given as an input in request.get or request.args or one of these inputs, right? So similarly, you can see whether that is there. If it is there, then you respond back. If not, do something else, right? So yeah, that's it. So you can just deploy it. And here there's no extra trigger specification because while creating the function, we already said use HTTPS and no authentication needed, right? So once behind the scenes, there's a lot of complicated things going on. It's just that as a user, you don't have to worry about it. Behind the scenes, they have, software engineering ideas, whatever software backs this up, is able to quickly create essentially something like a VM. It's not a VM, but something very much more lightweight, like a container, basically. All set up all the dependencies, isolated so that one tenant doesn't, get access to another tenant's data or functions or whatnot, business logic, right? So, and also put that on some resource on some data center and immediately make it available, right? So they're doing a lot of things behind the scenes. And it will also give you the URL, so you can trigger it. Right now it's hello world, but you can imagine, so this is a Python function which is just doing hello world, but you can, in that main function definition, you can change it, right? You can do many things. I mean, the simplest thing would be just do the Flask example that we have in our repository. Let's actually, yeah, I want to quickly say that we have a cloud function example, which is, I guess, fourth from the top, and also a Lambda function example, which is, I guess, fourth from the bottom or fifth from the bottom. So those you can, if you want to do like ML specific, instead of hello world, you can, if you want to change it, then you can change it. Okay. Let's take a break for 10 minutes. So after the break, I don't want to, I had some, I want to do the IDE stuff. I can do it, but it's not really, if needed, I can do it the next time also. But in general, after the break, it's up to you guys what you want to do, like, recap what we did on your own machines. If you have accounts, then, or if you're stuck on some installation or something like that, or some other step, talk to me and we can iron that out. Okay, so let's take a break.
Yeah.
Okay, so Okay, so we are in this folder, which is our original folder. I wanted to show you two things actually. Now that I see that one green thing here, it's called it's a nice app somebody kind of built, which lets you run large language models locally. Okay, so if you have a Mac or a Windows or even a Linux machine, you can run a large language model locally. What do I mean by that? So if I do, so actually I can tell you where I downloaded this from, which is, let's go here. So this is the website. Basically, it says get up and running with these particular language models. ChatGPT is one example of it locally. Okay, so why am I bringing this up? Is because it exactly follows this client server protocol that we've been talking about. Okay, so you can download it. It's available for Mac and Linux. Windows, it's not available, unfortunately. But there are other apps which do the same. Okay. But for Windows, you have Windows subsystem. For Linux, you can still do it, perhaps. So okay, so this is the executable that thing that I got when I downloaded. It just creates that one single file called Olama, is the name of the file. I'm just running it. / means just run that executable. Okay, and then the command I'm calling is serve. Actually, I think I'm already running it somewhere, so that's why it's trying to use the same app, the same port. So you would see a similar error, by the way, if you're trying to run your Flask app, and if you've already run it once and you haven't terminated it, and you try to run it again, if you have default the same port, it will say, okay, that port is occupied previously. Okay, so you will this error is common, especially you're doing running Flask app again and again. Maybe you're doing some development and you're retrying the command. Just know that if it's already the port, in this case, some 11,000 port, but in Flask case, it was 5,000. If it conflicts, then it will not run. Okay. Let me just check that it's not. Yeah, so it is, turns out it is running. So let me just Control C that. Okay, so you see a bunch of printouts. Don't worry about the printout. It's mostly very similar to the Flask app. Flask app was showing, hey, go to this route and then you'll see the web page or something, right? Or you can make a request. Here, it's not actually saying, it is saying kind of that hidden in somewhere here. Okay, it's just saying that on the local machine at port 11,434, I'm listening to requests. Okay, and then what you can do is on another machine you can another terminal, not machine. So it's just one more tab here. There are 3 tabs you can see. You can run. So what I did before the class is I did download a couple of models. These are really large models. You can see that one is 3.8 GB and one is 1.6 GB. This is the smallest ones, by the way. Some of the bigger models are even bigger, 7 GB or and so on. So I have these models already downloaded. If they're not downloaded, they'll download it. Okay, I didn't want to do that delay. So I just do Olama run. Okay, PHI phi is the name of one of the models. Okay, so let's run that model, and now you have exactly the same interface as what you would see in the on ChatGPT. I mean, it's not exactly the same, but kind of can say let's see if it's able to answer. Maybe not. Okay, it's not. Okay, this model is like, it's only 1.6 GB, so maybe it doesn't have, actually, it doesn't. Okay, so I think it's not a chat model in this one. This one is actually a more basic model where you just have to give a part of a sentence and it'll just complete it. Okay, it's a sentence completion program. It has not been tuned for, although it does say things like this. But anyway, this is a locally running thing. What I wanted to show you was that what we are doing here is like the client making requests. Okay, HTTP requests. And you can see that because if you go back to the other tab where I was running the server with the Ollama serve, you can see that it's saying what the request is. So it's saying request is, it's a successful request. 200 code means it's a successful request response cycle. Okay. And it's saying, okay, there was a post request that came in to which location /API/generate. So it's telling you where the request came and was it the server able to respond, so on. So it's exactly the same idea. Obviously, they've done a lot of engineering to make it in this application, but you can see, right? So the same basic idea, client server. We were running a Flask app ourselves, but these guys are running a full language model on the server side, and you can make requests from the client side. In fact, let me show you a request which is through another program. Let's say bye to this. Another program which is called CURL. Okay, CURL is a command. I think it was there in the slide deck also. The CURL is just a program. It's again very similar to LSCD. It's just an executable that's available on mostly Mac and Windows, Mac and Linux machines. WSL2 will have it also. If not, you can just install it. Okay. So CURL is just saying go to make a request to this URL with some data. Okay, -d means a data payload. It's going to make a post request, and the data is okay. Which model? The 5 model that we just tried, and what is the prompt? Okay, so we can just try this. And you can see a huge bunch of printout. Okay, so this is what behind the scenes response from the server is. Actually, it's showing a. So you can see the sentence is actually being constructed in the response side. So like red and orange dot as a result, comma, our eyes perceive the sky as being blue. So you can see the response is actually one at a time, and it's just responding with these basically what look like dictionaries. Okay, it's saying what model it is. So you can see that each row here is saying what model it is, what timestamp, what's the word response at that time, and whether it's finished or not. Okay, so all I'm trying to say is that you can make clients different. CURL is one utility. You could have made the same request from Jupyter, from the browser. I mean, from the browser, it'll be a little bit more complicated, but you could make same types of requests. Okay, you can change the programs that are making the requests, and they can all talk to the same server. Okay. In fact, Ollama project has a web UI, and you can create a UI which is very similar to ChatGPT's UI. So you can just run it if you want. Maybe next time you can try it. But anyway, I just wanted to show this as an example of a client server, real world 2024, most latest code. And the second thing I want to show is the code, VS Code. Okay, VS Code is an example IDE. I'm going to stick to just one IDE in this course. IDE stands for Integrated Development Environment. So the other IDE, another popular one is called PyCharm. If you have heard of it, it's from a company called JetBrains. So code dot means open the current folder in the IDE. Okay, so you can obviously do it in many other ways to open the IDE. Okay, so last time we did open this last time, if I recall. So this is the IDE that we saw last time also. So it's just opening a folder. And we have all these examples. Last time we even edited the Flask example. That's why there's a dot there. It's saying that you edited that file. Okay, which is again a useful IDE feature. So what I wanted to show is that this IDE also lets you connect to that server that we had on Amazon that we rented. Okay, so that way you can just program from here without command line fiddling. Okay, so the way you do it is you should install a. So on the left side, you see an extensions like this square boxes. One of the extensions that you should install is, ignore the other extensions. One of the extensions you should install is called remote-SSH. Okay. So this way you will be able to, we did SSH, some Ubuntu at some IP address. The same thing, this IDE will also do, and it'll open a local folder over there. That way, the local folder, if you are creating a new Py file, IPython file, whatever, it will be just showing up on your browser, and sorry, showing up on this IDE, and you can edit it. Okay. So I've already installed it. If you hadn't installed it, you install it, and then so you can say add a new host here. Okay, so, or how did I get this prompt? It's Command Shift P or Control Shift P. One of these, depends on Windows or Mac. And then you can just type remote SSH, add new host, right? So you can add a host, and you can tell what command you want to use. The only challenge here is that the PEM file has to be in the appropriate location. So that's going to be a challenge. I don't want to do it in real time, but except for the location of the PEM, the key file, which is very important, you can just put that prompt here, whatever SSH Ubuntu at whatever, and you should be able to connect through the IDE, and it'll open up on the left side. It'll open up exactly a folder, right? If in case there was an MLOps folder over there, you can just open up that folder, and you can make edits. You can run the program there also, so that nothing in your own local system is affected. Okay, so that way everything is clean. There's a development machine. You spun it up. You make edits. If you want to destroy it, you can destroy it as well, and it doesn't matter. Okay. Anyway, I don't want to overload with more information. So there's no more, I guess, lecture component now. So if you have any questions, you can just ask me, or you can try out what we saw today.